Hey everyone. All right, so let's get prepared for this exam. All right. First thing I want to do, I want to just provide you all with the topics. Here you go. So we're going to have linear equations, linear inequalities, and absolute value inequalities, functions, of course, right? Key features of graphs of functions, function notation, relation of functions, domain and range of functions, function behavior, composition of functions, evaluating functions, roots of functions, inverse functions, rational functions, and of course, long division and synthetic division. Mhm. So first, let's tackle equations and inequalities. Okay. Let's take a look at an example. So you could consider this to be like our first example, number one. All right. Let me resize that real quick. Then we'll read it. Go through. All right. So let L1 be a line through the point 3, 5, and -2, -5. We want to write an equation for of the line L2 passing through the point -3, comma 2, and is perpendicular to L1. All right. So first things first, right? Let's tackle that word perpendicular, right? We have two situations here, right? So anytime you have a slope that is perpendicular, right? Remember, perpendicular means it's like creates a 90-degree angle, right? Like it's gonna intersect with another line, right? So that's perpendicular, right? And then we have another situation called parallel, right? So parallel lines, right? Perpendicular lines, the slope is the negative inverse of the other slope, right? The other line, right? So whatever the slope of this line is, m equals, I don't know, 5. This slope is going to be m equals the negative inverse, right? So -1/5, right? Parallel slopes have the same slope, right? So this would be like m equals 3, and this would also be like m equals 3, right? So perpendicular is a negative inverse, parallel, same slope. Let's take a look at this, right? So the first thing I want to do is I want to find the slope for L1, right? So I want the slope for L1, right? And we remember what that was, right? So you have the change in Y over the change in X, right? So let's go from left to right. I have 5 minus -5 over 3 minus -2. Keep going throughout. A negative negative is a positive. This becomes what? 10 over negative negative is a positive. This becomes 5, right? And then 10 divided by 5 is 2. What do I want to do after that now, right? I want the slope for L2, right? So the slope for L2, right, is going to be the negative reciprocal, right? Negative reciprocal. So we're going to have negative, flip the 2, 1 over 2, just like that. All right. 1 second. Forgive me, I have a little pop-up. All right. All good, all good. Just making sure. Awesome. All right, we're good to go. Anyway, right? Now let's go through our equation of a line. We have, sorry about that. Apologize. We have y is equal to mx plus b, right? Now, this particular line is actually L2. This is the line L2 that we're looking for, right? What am I going to do? I'm going to plug in the slope that I found for L2, which is negative half, into this equation. So I have y is equal to negative half x plus b. And then we were given a point over here, right? What's our point? Our point was negative 3 comma 2. I'm going to plug that in for x and y and then solve for b, which is my, right, y-intercept. So let's go. So this is going to be 2 is equal to negative half times negative 3 plus b. Let's do a little math on this. 2 is equal to 3 over 2 plus b. Then we're going to subtract 3 over 2. What you do to one side, you must do to the other. 3 over 2. So now what do I have? I have b is equal to 2 over 1 minus 3 over 2. Now, you know, in order for me to subtract, I have to have the same denominator. Let's change that 1 into a 2. What you do to the bottom, you do to the top. So now what do I have? I have 4 minus 3 all over 2. Call that 1/2. So what is my equation of a line? My final equation, y equals negative 1 over 2x, excuse me, plus 1 over 2. And box your answer, and then that's it. All right, let's move on. All right. Next, we want to tackle inequalities. So I have two examples here. Let's take a look. Let me resize that. Awesome. Okay, let me just get that little pop-up out. There we go. All right, so we want to solve the inequality and express the answer using interval notation, all right? So let's do the first one, right? I have the absolute value of 2x minus 3, right, is greater than 4, right? That's the first question, right? So what does this mean? This means that I have a positive answer and a negative answer. So I'm going to have a negative 4 greater than 2x minus 3 greater than 4. So what am I going to do with that? I'm going to add 3 to both sides. What do I have? Negative 1 greater than 2x greater than, excuse me, I forgot to write the line, 7. Then we're going to divide by 2, which you do to one side, you know you have to do to the other, right? Boom. So now I have negative 1 over 2 is greater than x, which is greater than 7 over 2, right? Boom. So if I was going to do this in interval notation, right? I kind of have to read this a little bit backwards, right? So I would start here and I'd read it as x is less than negative 2, right? X is less than negative 2. So which numbers are less than negative 2? So we're going to go from negative infinity all the way up to negative 1 over 2, right? Parentheses, of course, right? Then we want to union that, right? With, let me erase this real quick. This is x greater than 7 over 2. So from 7 over 2, not included, we're going to go to infinity, right? And that's all the answers for my inequality right here. Okay. That being said, let's look at our next one. Bear with me 1 second. So I have 3x minus 1 less than 8. Let me get that real quick. 3x minus 1 less than 8. Let me just verify real quick. 3x minus 1 less than 8. Yep. 3x minus 1 less than 8. Okay. Awesome, awesome, awesome. So now, what does that mean? That means I have a negative number and I have a positive. I mean, I have a negative side and I have a positive side. So this is going to be negative 8, right? Less than 3x minus 1. less than 8. So what am I going to do? Just solve for x. Solve for x. I'm going to add 1 over here. What you do to one side, you have to do to the other, right? So now this is -7 less than 3x less than 9. And I'm going to divide by 3. What you do to one side, you have to do to the other, right? So now what do I have? I have -7 over 3 less than x less than 9 divided by 3 is 3, right? So what is this saying? This is saying that x is less than 3 and x is greater than -7 to 3, right? So literally I'm looking at the numbers that are in between. So -7 over 3, not included, of course, right? Up to 3. And there you go. That's my inequality. All of those numbers. Okay. So when it's greater than, you know what to do. When it's less than, you know what to do. This next one's a little challenging, but we're gonna get through it. All right. We're gonna get through it. Okay. Oh, I'm sorry. Let me bear with me 1 second. Okay, so for a quadratic function, f of x is equal to -x squared plus 8x plus 9, we want to find the vertex, right? So remember that the vertex is what? It's the axis of symmetry, which is -b over 2a, right? And then that's going to be our x coordinate, and then the y coordinate together, they make up the vertex, right? So let's go ahead and let's do that. Let me go back up to the equation I had, right? F of x is equal to -x squared plus 8x plus 9. Just to recap, remember that we want standard form. And standard form is what? Ax squared plus bx plus c. So a for me in this case is -1. B for me in this case is 8. And c for me in this case is 9. All right. Let's plug in these numbers right here. So this is going to be -8 over 2 times a, which is -1. Let's do a little math on that. Boom, boom. So I'm going to have what? 4. Okay. All right. So that's not my vertex, though. It's not my vertex. If anything, remember, vertex is a point, right? So what did I find? I just found the x coordinate of the point. Now I have to find the y coordinate, right? So to find the y coordinate, very simply, just plug it in. Just plug it in. This is going to become f of 4, right? Which is equal to -4 squared. Hold on, I forgot what I was doing. Plus 8 times 4. And I forgot the last number, plus 9. Okay. After you have this, just do the math on it. Nothing crazy, right? 4 squared, we know is 16 plus 8 times 4, what's that? 32 plus 9, right? This should be about 48, and then 48 and 9. This is like 57. All right? So that will be my vertex, right? It will be 4, comma 57. All right. Next, they ask us for our x-intercepts, right? Now, remember, your x-intercept, right? Hold on, oh yeah, put it on the line. Your x-intercept, right, is where the graph is going to cross the x-axis when y equals 0. Long story short, how do I find that? Set the equation equal to 0, right? So this is going to be what? -x squared plus 8 times x plus 9, right? After that, what can we do? Let's try and factor it. Very simply, let's try and factor it, right? So I want to factor out a -1, right? Just to make this a little bit easier. So this becomes x squared minus 8x minus 9. And then I want two numbers that multiply to give me a negative 9. And when I add them together, it'll give me a negative 8. So I have x minus 9, and I have an x plus 1. There we go. All right. Let's set both of these equal to 0. All right. So I have x minus 9 equals 0, x plus 1 equals 0. Let's solve for x. Add 9, subtract 1. And I had x is equal to 9, and I had x over here is equal to negative 1. Okay. These are my x-intercepts, right? But remember now, the x-intercept is a point. It's a point, right? I'm gonna do a little bit over here because of space, right? So this is the point 9, comma 0, and I forgot what the other one was already. Negative 1, and the point negative 1, comma 0. Those are my x-intercepts. Y-intercept. So the y-intercept is where the graph crosses the y-axis when x equals 0. So what does that mean? Plug in 0 for x, right? So now if I had y is equal to negative 0 squared plus 8 times 0 plus 9, right? Let's do the math on that. This becomes what? 9, right? So that's my y-intercept. My y-intercept is 0, comma 9. And then they ask us to sketch the graph, right? So what am I looking for when I sketch the graph? I want these intercepts, the x and the y's, and I want the vertex. That's it, right? Now, this graph that's here is not sufficient. So I will be attempting to draw my own graph here. But I'm going to kind of take it for granted a little bit. So I have, let's see, 1, 2, 3, 4. So 4, and let's say that was 4 and 57. Whoops. Oh, shoot. My mistake. I'm so sorry about that. 57 is up here. It's positive. What was I thinking? 4 and 57, right? And then we have, let me get my x-intercepts. It's negative 1, 0, and 9, 0. Right? And then I forgot what my y 0, 9. 0, 9. And what's this other one? 1, 0. Let's connect these dots then, shall we? Oh, what did I miss? Hold on. I missed something. 9, 0. Oops. Okay. That looks about right. Yeah, that's about right there. So now let's connect the dots. So this is going to be whoop, and then this one's going to be whoop, and that's it. All right. All right. All right. So new question. Believe it. So let f of x equals 2 times x plus 2 times 2 times x minus 1. We want to find what? The x-intercepts, right? We want to find those x-intercepts. Okay. So what I'm gonna do is I'm gonna combine like terms a little bit. Let's make this 4 times x plus 2 times x minus 1. That sounds about right, right? And then we're gonna graph this also, right? So let me find my x-intercepts. I'm just gonna set these two things equal to 0. Let's solve for x. Let's solve for x, right? So now I found my x-intercepts. Once again, the x-intercepts are points, all right? So this is the point -2, comma 0, and the point, I think it's +1, yep, +1, comma 0. Then we want to find our y-intercept. So the y-intercept is where the x-axis is where the graph crosses the x-axis when y equals 0, right? So, excuse me, let me say that again. The y-intercepts is where the graph crosses the y-axis when x equals 0. Sorry about that. So I want to know what is f of 0, essentially, right? So this is going to be equal to 4 times 0 plus 2 times 0 minus 1, which becomes 4 times 2 times -1. Yeah. And then this is what? -8. So my y-intercept is what? -8. And then, sorry. Sorry. Y-intercepts. Sorry about that. Okay, boom. After that, it would be nice to know the vertex, but not necessarily needed. We could do it though. Question didn't ask for it. We can just graph from here. So we have 0, -8, right? 0, -8. And then we have the where the graph is going to cross. Right here. Let's call this -2, comma 0. And then this one is 1, comma 0. Oops. Bam. There we go. Can't complain with that. It's not the vertex, by the way. Like my picture is kind of ugly. Um, that's not the vertex. It just looks like it is by the picture. Please don't go by that. I'm just kind of rounding things off. But one thing that I want to note, right? When you're drawing your graph, I want to see points on it, right? I want to see the dots. I want to see the actual point, right? So write that out when you're doing this question. Okay. All right, let's take a look at the next question. Let me resize. Okay. So this question says that g of x equals 2x cubed plus 11x squared plus 4x minus 5. We want to list all the possible rational zeros, right, according to rational zeros theorem, and then we want to find all the zeros for g of x. So let's take a look at that. So remember, right, for the rational zero theorem, right, it's always what? P over Q, right? Is that how you write? No, that's not how you write Q. There we go. P over Q, right? Remember that P is going to be your end number, Q, your beginning number, right? So what do I want? I want all the possible numbers that I would use to multiply to give me 5. So it's going to be plus or minus 1 and plus or minus 5. In the beginning, it's going to be plus or minus 1, and it's going to be plus or minus 2, right? That's it. Let's list out all these numbers, right? So first one we're going to have, let's say that we're going to have negative, excuse me, 1 second. There we go. Let's say we're going to have negative 1. We're going to have negative 5. Let's say positive 1, positive 5. Then I'm going to have negative 1/2. I'm going to have positive 1/2. I'm going to have negative 5/2. I'm going to have positive 5/2, right? And that's it. That's all the possible zeros that we have right there, right? That's the list of all the zeros. But now we want to find the actual zeros of the question, right? So I want to know, like, what are the actual factors for this? Couple of things that we can do. We could plug in each one. We could use synthetic division, long division to find out. What I recommend doing actually is I recommend actually what's it called? Using your calculator, right? If possible, look at the table of values or the graph, whichever is easiest for you, and then look at where the graph crosses the x-axis, right? If you find even one x that crosses the x-axis, consider that a blessing. That's one of your factors, right? You can use long division or synthetic division to find a new quotient that could be factored down from a quadratic using the quadratic formula, using completing the square, whatever you like, right? So let's take a look and let's begin. All right. So bear with me 1 second, please. All right, I will be there shortly. Trying to generate this graph, make it a little bit easier for us. Once again, on your regular calculator, you could do this on the table as well. All right, 4x minus 5. So, okay. Coming back now. All right. So, let's take a look at what I was able to come up with on my end. Please allow me to just resize this. This is really large. 1 second. Okay. I could even go a little bit smaller than that. That's too small. Okay. So here's what I want you to see, right? Here's what I want you to see and realize. Let me highlight this, right? So I found on the graph two of the points that crosses the x-axis, right? I just noticed that there was a third point there as well. Whoops. Let me see if I can get that up to you. 1 second. Okay. Bear with me 1 second. Uh, All right. So turns out I was able to graph and find all 3 points. It's okay if you only found two, right? You can find two and then use long division or synthetic division to find the last, right? In this case, I found all three, all right? So now, what do I have to do after that, right? We have to prove that this actually works, right? We can't just find it and then just, oh, that's it. No, you have to prove that it actually works. Now, there's a couple of ways we could prove this, right? We could prove this through long division. We could prove this through synthetic division, right? Or you can plug it in, right, to the original function and see that it actually works, right? So let me show you one by plugging it in. Um, was that a g of x? All right, so let's say, excuse me, let me get my pen. Sorry about that. So let's say that g of x, right? Instead of g of x, I'm gonna plug in -1. I figure that's the easiest one, right? Just to show you guys that this could work. So now I'm gonna have what? 2 times -1 cubed. Bear with me 1 second. Plus 11 times -1 squared plus, excuse me, plus 4 times -1, apologize, minus 5. Now, if this works, I should get 0 out. So let's see. 2 times -1 cubed, that's going to be 2 times -1. Um, 11 times -1 squared is going to be plus 11 times 1, right? And then we have plus 4 times -1, and then of course we have minus 5. Let's do the math on this. This is -2 plus 11 minus 4 minus 5, right? 2 plus 11 plus 4 minus 5. Okay. Let me just make sure that I actually type that in right. 2, 1 second. 4, 85. Okay. So now let's do the math on this, right? So -2 plus 11, that's going to give me 9 minus 4 minus 5. 9 minus 4 will give me 5 minus 5, which equals 0. It in fact works, right? So I can tell you that -1 is indeed a factor, right? So one of the zeros that we have is -1 comma 0. Let's look at another 0. All right. So let's look at a synthetic division one, right? Let's do the -5, right? So I already know that x equals -5 is a factor, but again, we have to prove it. Can't just go by it, right? We have to prove it, right? So for synthetic division, right, you're gonna have -5, and then I want the coefficients, right? The coefficients of this expression. So let me just rob that from over here. So we're gonna have what? 2, 11, 4, 3, 2, 1, and then zeros and -5. Boom, right? Now, if this works, I should get 0 at the end. Let's see. Bring down 2. Now, -5 times 2, that's going to give me a -10. Add these together. 11 plus -10 is going to give me 1. -5 times 1 is going to give me a -5. All right. Let's add these together. 4 plus -5 is excuse me. 4 plus -5 is -1, right? -5 times -1 is +5. Add these together. That gives me 0. Done, right? So this is in fact, -5 is in fact a factor. So now I can say -5, comma 0. right? And another one that you can use long division, right? So I see that 0.5 is one of the x's, right? So 0.5, remember, is the same thing as 1/2, right? So now let's say I wanted to do long division for this. So I have x is equal to 1/2, right? Or 0.5, right? So what you want to do, you want to put this as a factor, right? So I'm going to multiply this by 2. If I do to one side, I got to do to the other. So now I have 2x is equal to positive 1. I'm going to subtract 1 from over here, which you do to one side, you do to the other. So now I have what? 2x minus 1 equals 0. 2x minus 1 is what I'm looking for, right? To do my long division. So we have 2x minus 1, right? And then you get the whole equation from above, right? So this should be what? 2x cubed plus 11x squared plus 4 minus 5. Now, I showed you 3 different ways to do this, right? Plugging it in, synthetic division, long division, right? I'm not telling you that you have to do all 3 or you only have to do one way. It's up to you, however you want to prove it. Whichever way is easiest for you. All right? No pressure. All right? Whatever works for you. I'm just going through the motions of all 3 because I'm trying to show you the possibilities of what you can do. All right, now let's go through this. So again, if this works, I should have remainder 0. All right, let's go through. So 2x goes into 2x cubed, what? X squared times. Now, x squared times 2x is going to give me a 2x cubed, right? Now, then I'm going to do x squared times -1, which is going to give me a negative x squared. What happened there? There we go. Right? Now, remember, this is a polynomial, right? So we're going to subtract these. So 2x cubed minus 2x cubed, that will cancel out. 11x squared minus negative x squared. That's going to give me what? That's going to give me a 12 x squared. Bring down, oh, I forgot the x right here. Bring down positive 4x, right? Now 2x goes into 12x squared plus 6x times. Now 6x times 2x will give me a 12x squared, and 6x times -1 will give me a negative 6x. Again, this is a polynomial, so make sure we subtract. So 12x squared minus 12x squared, that cancels out. 4 minus negative 6x, this is going to be a positive 10x. Bring down that negative 5. Now 2x goes into 10x positive 5 times, right? Now 5 times 2x is 10x. 5 times -1 is -5. I'm sorry, I don't know why that didn't, right? This is a polynomial again. 10x minus 10x, that cancels. -5 minus -5, that's going to give me remainder 0. So 2x minus 1 is indeed a factor, right? So that means that x equals 1/2 is in fact a 0. So we have what? 1/2 comma 0, right? I'm looking for points. That's what I'm looking for, right? These are the zeros. Do not tell me x equals 3, x equals 1. No, that is a line. That is not a 0. Zeros are points. All right. Another thing to note as well, I want to talk about the synthetic division first, right? Now, this was a very perfect polynomial that we had. In the event that you have a polynomial that is missing a exponent, right? Let me give you an example. Let me give you an example I'm trying to hint at. Say I have 2x to the fourth plus 3x to the second plus 4x plus 2. I'm just making something up off the top of my head, right? Notice how I'm missing the x cubed term. right? If you're doing synthetic division, right, the numbers that you would put here for the coefficients would be what? 2, 0, 3, 4, and 2, right? So if we're missing a term, you must put in a 0 for that. Likewise, if I'm doing long division, right? Same issue. If I had this polynomial here, I would write the polynomial on the bottom out as 2x to the fourth plus 0x cubed plus 3x squared plus 4x plus 2, right? This will help you to avoid any errors when you're doing your long division, all right? So that's my only little tip in regards to this. And once again, it's a choice. If you want to plug in the values and prove to me that it's 0, I'll take that. If you want to do the long division, I'll take that. If you want to do the synthetic division, right? This is the long division over here. This is a synthetic division. I'll take that as well, right? Prove to me that remainder is 0, and my answers are points, not lines, right? Not x equals. It is -1 comma 0. It is -5 comma 0. It is 1/2 comma 0. All right. You have calculators. You can find these numbers in the calculator to make your life a little bit easier. I do want the list of all the numbers as well, right? That is actually part of the question. List all the possible rational zeros. If there's no list, you just lost points. All right. Do not just find the zeros and that's it. All right, let's keep going. All right. Let us keep going. 1 second. Bear with me 1 second, please. All right, let's talk about this. So the graph of a parabola, y equals f of x, has an axis of symmetry at x equals 1, a vertex at 1 comma 5, and at 0, f of 0 is equal to 3, right? So in any order, determine the following, right? We want to write the equation of the parabola in vertex and standard form, state the domain and the range of f, and we want to sketch the graph of it. Okay. So let's start off with the equation, right? So just to recap, vertex standard form is y equals x minus h squared plus k, right? Okay, let's go back to the vertex now. So they said that they had a vertex of 1 comma 5. Remember, this is h comma k. There it is, right? Just plug it in. So this is y equals x minus 1 squared plus 5. That's it. That's the equation. That's all we had to do, right? Wait, I'm forgetting something. Sorry about that. I made a mistake. I forgot the a that was in front here. My mistake. There's also an a right here as well. Now, it's easy to plug in the h and the k, but we actually have to find what is that a that's there. How can we find that? Use the point that we were given. F of 0 is equal to 3, right? So what does that mean? That means that when x is 0, y is 3. Let's plug that in. So I'm going to have 3 is equal to a times 0 minus 1 squared plus 5. Let's do the math on this. This is going to become 3 is equal to a times -1 squared plus 5. That's going to be +1. So 3 is equal to a plus 5. I'm going to subtract 5 from both sides, which you do to one side, do to the other. Ba, ba, ba. So a is equal to -2. Boom, right? So what is my final equation, my real equation? It's y equals -2 times x minus 1 squared plus 5. This is it right here. Sorry for the confusion right there. All right. Just to make it pop a little bit, let me highlight it for you so you can see. All right, that's it. Okay. Let's talk about domain and range. All right. So domain, this is all of the x values that your function exists at, right? Now remember, there's two things that's illegal that we can't do, right? We cannot divide by 0, and we cannot just make sure, hold on one sec. Let me just make sure something. All right, yeah. We cannot divide by 0, and we cannot take the square root of a negative number. We have none of that here. So my domain is what? Negative infinity? Ooh, that's not good. Let me try that one again. Negative infinity to positive infinity, right? Okay. Now, let's talk about my range. Okay. So range is all of the y values that the function exists at, right? So let's make some observations here. I see that a is actually -2. So that means that this is a parabola that's going to open up downwards. So it's going to look like this, right? All right. And what else can I say about that? That means that, well, let me draw back that picture. I'm sorry. Or premature. All right. That means that I have a maximum value at the vertex, and then it's going to go down from there, right? So the vertex y coordinate, right, is what? 5, right? So the y coordinate is 5. So what does that mean? I know it's going to go from negative infinity up to 5, right? From negative infinity up to 5. What happens if it was the other way? What if it was a like this and it was a minimum, right? It would go from the vertex all the way up to infinity, right? So if it was a regular parabola where a was positive, it would go from the vertex up to infinity. All right. Good stuff, good stuff, good stuff. All right. What's the next thing that they asked? Sketch the graph. All right. So let's sketch this graph. Let's do it. All right. Also, let me write down this point right here. This point is actually really important, 0, comma 3. All right. Why is that important? Right? That is the dun, 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 what? Y-intercept. All right. So what's my vertex again? I forgot. 1, comma 5, right? So I'm gonna come across to 1, go up to 5. 1, 2, 3, 4, 5, right here. Vertex at 1, comma 5, right? I do need to find my x-intercepts. I didn't find that. Oh no. So we're gonna have to go through that and find that. But I did find my y-intercept, right? So 0, 3. So there we go. 0, comma 3. That's my y-intercept, right? Notice that I'm labeling my points, right? I want you to label your points too. Don't just give me a drawing and be like, okay, there. No, that's wrong. Label your points. All right. Anyway, x-intercepts, right? So the x-intercepts, right, are the values of x, right? No, is where the graph crosses the x-axis when y equals 0. So long story short, what do I have to do? I have to set the equation equal to 0. Very simple, right? And then just do the math on it. Nothing crazy. -2 times, what's that? X squared minus 2x plus 1 um plus 5 over here. What's this? -2x squared plus 4x whoops, sorry about that. -2 plus 5. Let's combine like terms. -2x squared plus 4x plus 3. Okay, not bad, not bad, not bad. You could do whatever you want. right? If you want to factor it and set the two factors equal to zero, go ahead. If you want to use a quadratic formula, go ahead. Or if you want to complete the square, go ahead, do that. I don't care, right? For me, I'm going to complete the square. Just happen to like that one, right? So I'm going to subtract 3 from over here. What I do to one side, you don't have to do to the other, right? So I have -3 is equal to -2x squared plus 4x. Once again, if you don't remember this, it's on the formula sheet. Look it up, right? So let's divide by -2. What we do, the reason why I'm doing that for completing the square, I need my a term to be 1, but not just the a in front of the x squared. Everybody gets divided by that -2, right? So now what do I have? I have +3/2 is equal to x squared. That's what I want, right? Minus 2x. Okay, right? And then remember, we're gonna use our axis, -b/2a squared, right? In this case, I have what? Negative of -2/2 times 1 squared. Call that 1 squared, right? And that's what I'm going to add on both sides. So I'm going to add 1 here, and I'm going to add 1 here, right? On the right-hand side, this is going to become what? 2/2 plus 3/2 is equal to, let's factor this. This is going to be x minus 1 squared, right? Put this together. This is 5/2 is equal to x minus 1 squared. I want to solve for x. So I'm going to square root both sides. What you do to one side, you have to do to the other. So now what do I have? I have plus or minus square root 5 over square root 2 is equal to x minus 1, right? So let me rationalize this denominator real quick, because remember, it's illegal for me to have radicals in my denominator, right? So I'm going to multiply this by radical 2. What you do to the bottom, you do to the top, right? So now I have plus or minus square root 10/2, right, is equal to x minus 1. I'm going to add 1 over here. What you do to one side, you do to the other, right? So now what do I have? I have x is equal to 1 plus or minus square root 10/2, all right? That's simple. If you want, you can condense this a little bit, maybe put it under the same denominator. You could make it possibly 2 plus or minus square root 10/2. That works as well, right? So what did I just find right there? These are my x-intercepts, right? These are my x-intercepts. One of them is 2 minus square root 10/2, and the other one is 2 plus square root 10/2. Come back up here. So I have a point right here. I have a point right here. Notice my graph is not drawn to scale, but it's labeled. That's the big deal. It's labeled. Label the graph, right? So what was this one? This is going to be 2 plus square root 10/2 comma 0. And this one over here will be what? 2 minus square root 10/2 comma 0. Bam, there goes the graph. Full credit. All right. Now, I don't think you guys are gonna have a really hard polynomial like this on your exam, meaning that I think you're gonna have really beautiful x-intercepts for your exam, but essentially this is what it would look like. All right. Give you guys an idea. Let's look at our next question. Let's pull this over here. Bear with me 1 second, please. Okay. All right. So For the function f of x is equal to x to the fourth power minus x to the third power minus 6x squared, we want to list all the possible rational roots of p of x, right? According to the rational zeros theorem. We're going to factor this completely. Then we want to find all the roots of the equation. Then we want to determine the end behavior of the graph. Then we want to determine the y-intercept of the graph. Then we want to determine the x-intercepts of the graph. Then we want to determine the local behavior of y equals p of x near the x-intercepts. And then we want to use this information to sketch the graph. All right. A lot of things to do here. A lot of things to do here. All right. Let's tackle them one at a time, right? So the first thing we want to do is we want to do A. All right. So for A, here's what I want to start off with. I have x to the fourth minus x cubed minus 6x squared, right? Um, Thinking about this one. I think I want to do B first, and then I'm going to come back to A for a second, right? I just want to be sure about something. So let me try B, where they ask us to factor completely. Real simple to factor this. Greatest common factor. What is it? X squared. What are we left with? X squared minus X minus 6, right? So factor this one step further. We have x squared times x minus 3x plus 2. There we go. Those are our factors right there. So, okay. So for the list of factors, what was throwing me off is I didn't see a constant term here. So I was trying to figure out in my head, like, if this could work or not, right? So I guess what we're going to have to do here, right? Remember, it's going to be P over Q, right? Technically speaking, right, our last term is the negative 6x squared. So that's going to be our Q, right? So this is going to be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6, all over plus or minus 1, right? So that should give us zero, all of our real zeros. Let me say that. Ooh, almost misspoke. Now, they want the list, so you're going to list them all out, right? So you have what? -1, -2, -3, -6, +1, +2, +3, +6. All right. So these are all your possible zeros. That's question one, right? Now, excuse me, that's question A. For B, they asked us to factor it completely. This is the factor right here. You can kind of tell from the factor what are the actual roots, right? You just set the factor equal to 0, and then that's the answer for C, right? So let me just do that, right? I'm going to have x squared equals 0. I'm going to have x minus 3 equals 0 and x plus 2 equals 0, right? We're going to find those factors. So square root at x, so then I have x is equal to 0, add 3, add 3. So I have x is equal to 3, subtract 2, subtract 2. So I have x is equal to -2, right? So what are my roots? My roots are 0, 0, open parentheses, 3, 0, -2, comma 0. These are my roots. All right. Those are the roots. All right. Let me go back up. I don't remember what D was. They want to know the end behavior of this, right? Well, this is a fourth degree polynomial, right? And the leading term is positive, right? The leading term is positive right here. X to the fourth is positive, right? So What should my end behavior be? Your end behavior should be something that looks like the palabra. So you might not know what's going to go on in the middle, but you know that something like this is going to go on, right? This is your end behavior, right? You could tell it to me like this, or you could say, as x is going to negative infinity, f of x is going to infinity. And as x is going to infinity, f of x is also going to infinity. I'll take either explanation, or if you want to do both, I'll take both, right? Whatever is easiest for you. All right. So either give me a drawing or describe it to me, right? E, determine the y-intercept of the graph. Very simple, right? Y-intercept, you just plug in 0, right? I happen to have done that already, right? So when I plug in 0, I get back out 0. So that's my y-intercept, A, B, C, D, E. So y-intercept is 0, comma 0, right? But if you want to verify it, right, you have your equation up here. This is y equals x to the fourth minus x cubed minus 6x squared. You can actually plug in the zeros for me to verify that. I'd appreciate that. All right. So f of 0 would be 0 to the fourth power minus 3. I'm seeing minus 0 to the third power. Um, 1 second. Minus 6 times 0 to the second power, right? And boom, that's 0. So that proves that this is the y-intercept, right? Not so bad. Let me go back up because I don't remember what's next. A, B, C, D, E, F. Okay. They want the x-intercepts, right? X-intercepts. Well, what do you know, right? The roots, they happen to be the x-intercepts, right? So these are the roots and x-intercepts, right? Technically speaking, the x equals 0, x equals 3, x equals -2, right? Technically speaking, this is the roots. Technically speaking, right? But the x-intercepts are actual points. So these are the x-intercepts here. Inter. Okay. Okay, so found the y, found the local behavior. Okay. So now, right? Here's where our multiplicities come into play, right? So for our roots, right? I'm gonna just pull to the side right here for our roots, right? We have 0, right? With multiplicity 2, 3 with multiplicity 1, and -2 with multiplicity 1. Okay, right? Remember what happens now, right? At whenever you have multiplicity that is even, right? We're gonna have a bounce off of the x-axis, right? Whenever we have multiplicity that is odd, we will break through the x-axis, whether that's up, down, whatever, right? So that's what we're gonna have here, right? Let's look at here and then Okay, so now we can get to the graph. All right, now we can get to the graph. So this is F. Let me just take a look at my points. Da. Okay, we can get away with a small graph. All right. Y-intercept is at the origin right here. So I'm gonna label that one after. So what do I have? 3, 0, and negative 2, 0. So 1, 2, 3. All right. And then 1, 2. All right. Now, did they ask me about the end behavior? I skipped D. OMG. Okay, good. There it is. All right, I had it. All right. So this is to the fourth power, of course, right? So what's going to happen here? I know that at 0, I have multiplicity 2, so that's going to be a bounce. And I know I'm going to break the graph at the 3 and at the negative 2. So let me label those now. So this will be 3 comma 0. This is the 0 comma 0. And then this one is the negative 2 comma 0, right? We know what our end behavior is. Our end behavior is this, right? That's our end behavior, right? So what's going to happen, right? Remember, multiplicity 1 at x negative 2 comma 0. Multiplicity, sorry about that. Multiplicity 1 at 3 comma 0, right? But multiplicity 2 at 0. So what's going to happen? I'm going to break this. I'm going to come up here, bounce off of this, and then connect, just like that. And that's my graph, right? So this is y equals x to the fourth, and I forgot the rest of the graph. Hold on. The rest of the equation, excuse me. It's going to be negative x cubed. And then I believe it's negative 6x squared. Yes, negative 6x squared. Negative 6x squared. All right, so that's your graph right there. All right. So important things to note, multiplicity 2 is a bounce, multiplicity 1 is a break, right? We go through the intercepts, right? And you all know how to find the x-intercepts, no problem. You know how to find the roots, right? And behaviors, remember that when it's positive, end behaviors go up in both directions. All right. If it was odd, end behavior will be like this. And behavior for odd functions is like x cubed. All right. That's the end behavior for an odd function. Okay. All right. So we should be good with that. Let's take a look at the next question. This is the question that's going to get you probably the most amount of points on the exam because it is the easiest, right? It is the easiest. You don't have to draw nothing. Drawing is provided. All you have to do is just tell me about it. What could be more simple than that? All right, here we go. Just bear with me 1 second. Okay. All right, I'll work with that. So it says, let f be the following function described by the graph. So it says fill in the blanks, right? What is the domain of this graph, right? So the domain, right? It's the x value. So I'm going from here to here, right? So let me try that one again. Here to here, right? So what's my domain? My domain is going to be brackets, -3 to what? 2, open parentheses, right? Because it's an open circle, I know that this is not included, right? And because this is a darkened circle, I know that this is included, right? So if this was should look something like that, I guess, right? Anyway, what's the range, right? Remember, range is all of the y values that the function exists at. Why that's not erasing. Okay, y range is all of the y values of the function exist at. So we're going from what? -5 up to 4, right? Sorry, 1 second. Okay. Okay, so we're going from -5 up to 4. So my range is what? -5, bracket, of course, comma, 4. Oh, bracket as well. Sorry. That's my range, right? Now it says write all x where f is negative in the interval. So they're asking you, right? Where is this graph decreasing, right? So very simply, we're decreasing from here to here, right? Using the x's, right? So we're going from 0 to 2, right? From 0 to 2. So it is decreasing from 0 to 2. Now it's going to ask you, where is it increasing from, right? Opposite. So it's increasing from here to here, right? So we're going from -3 to 0, right? So parentheses, -3 to 0, right? Now, it's asking you, is this function a one-to-one? Yes or no, right? If it is one-to-one, it would pass the horizontal line test, meaning that if I draw a horizontal line through it, it would only hit that horizontal line one time, right? In this case, it failed it, right? It hits the horizontal line twice. So no, this is not one-to-one, right? Now they're asking for your x-intercepts. Very simple. X-intercept right here, x-intercept right here, right? Let me erase that though, because I don't want to block the open circle. So your x-intercept is what? -2, comma, 0. All right. And technically speaking, looking at this is an open circle at 2. So technically it's kind of not really there, right? But the one on your test will make more sense, right? For me, I would say that it is there, right? So I would call that an x-intercept. All right. Anyway, y-intercepts, right? So the y-intercept, where does the graph cross the y-axis when x equals 0? So this is what? This is 0, comma 4, right? Now, is there a local minimum? No, there isn't, right? So none, right? Is there a local maximum, right? Yes, it is. It's the y-intercept, right? That would be your local maximum, right? And you could tell me the maximum. You could just say like max at um y equals 4, or you can give me the point. I'd kind of prefer the point though. I really prefer the point, to be honest with you. So that would be 0, comma 4. All right. All right. Anyway, they want to know what is f of -1. So when x is -1, let me erase this horizontal line real quick. When x is -1, what is the y value? It's 3, right? Boom. Just use the graph, right? You go right from -1, go right up to where the graph is, and what's the y value corresponding to that? 3. Done. Simple. F of 2, right? So when x is 2, right? What is the y value, right? DNE does not exist. All right. And that's about that. I'm on the fence about this x-intercept business because of that open circle. You know what? I'm gonna take it away. I'm gonna take away the 2, comma 0 because of the open circle. All right. Because I feel like technically it's not there. So yeah, it only crosses the x-axis at one point. Let's go with that. Okay. I don't believe your test will give you one as complicated as this, but something good to talk about. All right, let's take a look. Our next example. Give me 1 second, please. All right, let's run through this. So, given the functions g and f described by the graphs below, so we have g, we have f, cool. Find the domain of f. Okay, so let's look at the domain of f, no problem. Right? They want the domain of f. So for f, domain is what? Negative infinity to positive infinity. They want the range of f, no problem. Right? So for the range, is right now you notice that this is a downward facing opening palabra, so we have a maximum, so you go from the maximum down to negative infinity, or actually it's the reverse, negative infinity up to the maximum, right? So what do we have? We have a maximum at 6, so this is going to be what, from negative infinity up to 6. That's your range. Okay, an interval on which f is increasing, right? So particularly f they asked about. So f is increasing from negative infinity up to what? Up to 3, right? From negative infinity up to 3, right? We use the x for that. So f is increasing from negative infinity to 3, right? Now, it's not including 3 because that's a turning point, right? Okay. An interval in which f is decreasing. So it's the reverse, right? So f is decreasing at, oh no, from the 3 to infinity, right? From 3 to infinity, right? That's the decreasing. All right. Same question. They want to know the domain of G, right? So the domain of G, same thing, negative infinity to positive infinity. So domain of G is equal to negative infinity to positive infinity, right? Range of G. Let's talk about the range. So the range of G, right? This has a minimum, right? So we're gonna go from the vertex right here all the way up to the infinity, right? So what's my range? I'm going from -1 to infinity. That's my range, right? So is right from -1 to infinity. And that's it. Right? Sorry about that. Let me just fix up some of these real quick. Domain and ranges have the brackets when necessary, but not the decreasing, increasing. Right? So this should actually be a bracket. Sorry about that confusion, right? Okay, an interval on which G is 1 to 1. All right. So remember, 1 to 1 means that it passes the horizontal line test, right? Um, I'm really tempted to just say that there is not an interval at which G is 1 to 1. There, you could argue with me that there is a point on which G is 1 to 1, right? But not an interval, right? So I would say at x equals 3, comma, x equals 3, y and y would be -1 at that point, 3, comma, -1, the vertex, right? This point could probably pass the horizontal line test for 1 to 1, but the rest of it cannot, right? So if they if they're asking for an interval, I would say none, or you could say, technically speaking, from 3 to 3, right? Like we would in the homework, right? So an interval on which G is increasing, you could say open parentheses, right? 3 to 3. That would be the point, technically speaking, right? Technically speaking. All right. Let's keep it moving. Let me just resize this 1 second. Okay. So we have f of x is equal to the square root of x squared minus 10x plus 25, and g of x is equal to x squared minus 4 over the square root of 1 minus x. So they want to know, what is the domain of f and g? Let's do that, right? So the domain for f is, right? Now here's the thing, right? I have a quadratic underneath the parabola, right? So for the quadratic, negative infinity to positive infinity, we're good to go, right? But the quadratic, I'm not allowed to take, right, the square root of a negative number, but it's a quadratic, right? Is there ever going to be a value for x that will make this negative, right? No, right? Because it's a quadratic. Every value you plug in there, whether it's negative or positive, is going to spit out a positive number, right? Because x squared grows larger than the negative 10x, right? So what's my domain? Negative infinity to positive infinity. Um, Domain for G is, now all I care about is I care about that denominator. I cannot divide by 0. And I cannot take the square root of a negative number. So long story short, what do I want to do? I want to take what's inside there, the 1 minus x. I need this to be essentially greater than, excuse me. I need this to be greater than 0, right? And that's it, essentially, right? So I'm going to subtract 1 from here. When I do to one side, I do to the other. So now I have negative x is greater than -1. I'm going to divide by -1. When you do to one side, you do to the other. Remember that whenever you divide by -1 with an inequality, you flip the sign. So this becomes x is less than +1. So what is my domain? All the numbers that are less than 1, but not including 1 because I cannot divide by 0. Not including 1. So the domain is negative infinity up to 1 parentheses. All right. Okay, what's the next question? Okay, into one of those. Okay, so they want to know what is f of g of 0 and what is g of f of 0 and what is f of g of 0. Okay, they asked the same question twice right there. No, no, no. I'm sorry. I'm sorry. I misspoke. That is f times g of 0. Okay, I misread that. All right. Let's do the first one. F of g of 0, right? So what does that mean? That means I'm literally going to take g, I'm going to plug it into f, and I'm going to plug 0 into g, right? So let's take a look at what that's going to look like, right? So I'm going to have the square root. It's going to be that's the x squared. 1 second. Minus 10x plus 25 minus 10 plus 25, right? And then what's my g of x? X squared minus 4. But instead of x squared, I'm going to have this squared minus 4 over the square root of 1 minus 0, right? Let's do put a 0 right here as well. Let's do it over here. So this would be 0 squared minus 4 over square roots 1 minus 0. Okay. And all we have to do is just evaluate this. Nothing crazy. This is square root. What's that? -4 squared minus 10 times uh what's this? -4 plus 25. We'll do a little math on this. This is gonna be what? 16. Oh, excuse me, square root. 16 plus 40 plus 25, right? Let's do the math on this. Oof. 56 plus 25, which is square root 81. Just doing it in my head, which is 9. Okay. Oh boy. What a question. Now let's do g of f of 0. G of f of 0. So literally, what does that mean? That means I'm going to take f and I'm going to plug that in for g, right? And then I'm going to plug in a 0 into f on top of that, right? So let's start it off, right? So this is going to be something squared minus 4 over the square root, excuse me, of 1 minus x. And then x is square root x squared. So I'm going to say square roots. I'm going to put 0 squared. I'm just going straight to plugging it in minus 10 times 0 plus 25. Just plug this in. This is 0 squared minus 10 times 0 plus 25. Let me just verify. Awesome. Okay. Little math, boom, 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 and we're good to go, right? So the top is going to be what? Square root 25, and the square will cancel out. So this is what? 25 minus 4 over, what's this? Ooh, we got a problem. We got a problem. This is going to be what? 1 minus 25, right? Now remember, I can't take the square root of a negative number, right? So what does that mean? This one has no solution. Or you know what? Let me not say no solution because that's implying something else. Let me change that up. It does not exist. So what does that mean? That the value that I chose for X in this question, which is zero, right? It doesn't work. Right? It doesn't work. It does not exist at that point. All right, F times G of zero. Let's take a look at that, right? So this means F of zero times G of zero, right? But I'm not even gonna go through this, right? Why? Because I actually wait, no, I can go through this. I'm sorry. I'm sorry. So we have what? We have square root zero squared minus 10 times zero plus 25. Yeah, I'm mistaken. Times, what's our G of zero, right? So G of zero is zero squared minus 4 over square root 1 minus 0. Yeah, that's it. In parentheses. Okay. So then now let's do the math on this. This is just what square root of 25, call that 5 times what's this? Negative 4 over 1. No biggie. So this is what? Negative 20. And that's it. That's our answer. Not too bad. So that's F times G of zero. Right. Then we had G of F of zero was one of the questions. And then we also had F of G of zero, which was another question. And that's it. All right. All right. Sorry about that. So, okay. The way this is written, it looks a little funny. So I'm going to assume that they mean log of base 3 of like square root 3 over 9. I feel like that's what's being asked here, right? It could either be that or it could be log base 3 of square root of 3 over 9, right? I'm not clear on what this is, but I feel like it's the first one. In either case, let's just do both, just for the practice, so to speak. All right. So, sorry about that. Let me just close parentheses on this. Okay. So, say I wanted to find the answer to the first one, right? 3 raised to what power is this answer here, right? Now, there's a couple of ways we could do this. We want the exact answer, right? So we can expand this. We can expand this one, right? Because we know that this would become what? Sorry, log base 3, square root 3 minus log base 3 of 9. You kind of just play with the rules of the logarithm. Remember that I can pull the exponents down front. So this becomes 1/2 log base 3 of 3 minus log base 3 of 9, right? So log base 3 of 3 is asking me 3 raised to what power is 3? We know that that's just 1. So this would be like 1/2 times 1 minus log base 3 of 9, right? We know that 3 raised to the second power gives us 9. So that's just 2, right? Doing the math on this, I'm going to have 1/2 minus 2 over 1. Let's multiply this by 2. We do to bottom, do to top. So this becomes what? 1 minus 4 over 2. Call that negative 3 over 2, right? So that would be my answer here. All right. Now, let's say that we're going to do the one on the right. I would pull out, right? The one on your test will be very clear. It won't look like this, right? But I couldn't tell from this the way that this is typed which one this actually is. So I'm just doing both just for the practice to show you guys, right? So first things first, you can pull the exponent out. This would be 1/2, right? Log base 3 of 1/3, actually, right? Because 3 divided by 9 is 1/3, right? We can go a step further, right? We could say 1/2 times log base 3 of 1 minus log base 3 of 3, right? Going through the math, anything raised to the 0 power is 1. So I could tell you that this would be 1/2 times 0 minus anything raised, 3 raised to the 1 power is 3, so this will be 1. So this is just what? Negative half. Okay. I don't know which one is the actual question because it's not clear the way it's typed, but here's how you would do it if it was either one of the ones that I wrote here. Right? Another situation is popping into my head. This could have also been reduced to log base 3 of square root 3 over square root 9, which would be log base 3 of square root 3 over 3, right? And if it was that case, right, I think I'm going to come out with the same answer, but let's verify. Let's verify. So I'm going to have log base 3 of square root 3 minus log base 3 of 3, right? Can bring this down. So this is 1/2 log base 3 of 3 minus log base 3 of 3, right? So this becomes 1/2 times 1 minus 1. So 1/2 minus 1. This is going to give me a negative 1/2. Yeah, same answer. So a little bit of an alternative way of doing that one, I guess. Right. Okay, again, not clear on how that was typed. All right. Want to talk about composition of functions now? Okay, so we have f of x is equal to 3x squared minus 2x, and g of x is equal to 5x minus 1. So we want to find what is f of g of x, right? So I'm literally going to take g of x and plug it into f of x. So this is going to be 3 times, right? Instead of the x, g of x, 5x minus 1 squared minus 2 times 5x minus 1. The rest of this is just fun, just expand it. Let's see what happens, right? So this is 3 times, what's that? 25x squared, right? Minus 5x minus 5x. Um, ba, 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 plus one, right? And then we have minus 2 times 5x minus 1. Combined like terms, I have 3 times 25x squared minus 10x plus 1. Minus 2 times 5x minus 1. All fun stuff from here, right? Distribute the 3, distribute the 2, combine like terms, we're done, right? So this is what? 75x squared minus 30x plus 3 minus 10x plus 2, right? Combine like terms now. What do we have? 75x squared minus 40x plus 5. There we go. Can't beat that. All right. Do some more composition. 1 second. All right. So we have f of x is equal to x squared minus 4x plus 7. G of x is equal to x minus 7. And we want to know what is f of g and what is g of f. All right. So f of g. I'm literally going to take G and I'm going to plug it in for F. So it means this. It means F of G of X. That's exactly what it means, right? So take it, plug it in, right? So this is going to become what? X minus 7 squared minus 4 times X minus 7 plus 7, all right? Expanded, combine like terms, all that good stuff, right? So this is what? X squared minus, what's that? 14x plus 49, something like that. Right. Um, that parentheses minus 4 times x minus 7 plus 7. Let's distribute, combine like terms. This is x squared minus 14x plus 49 minus 4x plus 28 plus 7. Right? Combine like terms. This is x squared. Then we have minus 18x. Then we have 49, right? Plus 7, that's gonna give me 56, and then 56 plus 28. What is that? 28, that's like 76 plus 8, that's 84. Just add the numbers together, and that's it. All right. Okay, let's do G of F. What that means literally is that this is G of F of X. So I'm literally taking F of X and I'm plugging it in for G, right? That's what I'm doing, right? So what's G? X minus 7, right? So big parentheses, minus 7. And then X squared minus 4X plus 7, all right? Drop the parentheses. What do we have? We have x squared minus 4x plus 7 minus 7. These are going to cancel, so I have x squared minus 4x, and that's it. Uh, Not too bad. Oh, I forgot. Let me do one of these. Okay. Okay. Yep. That's all they asked for. This is another easy part of the exam. Okay, let's start from the top. G of 1 is equal to, so I'm looking at graph G right here. So when x is equal to 1, right? What is the y value? It's right here. It's 3, so this is going to be 3. Next one, f plus g of 1, right? What does that mean? This means f of 1 plus g of 1. Just keep it simple, right? So when x is 1, the y value is 2 here. Plus when x is 1 over here, the y value is 3. 2 plus 3 is 5. Okay? Next one, f minus g of 4, right? So what does that mean? That means f of 4 minus g of 4, right? So f of 4, so when x is equal to 4, and here, what is the y value is 5. And then minus g of 4, so when x is equal to 4, what is the y value? 0. 5 minus 0 is 5. Done. All right. Next one. This is g times f of 3, right? So this is like g times f of 3, right? And it means g of 3 times f of 3, right? So when x is 3 for g, right? The y value is -1. When x is 3 for f, the y value is 6. Multiply these together, you get -6. So now we want f of g of 1. Not too bad, right? So start from the inside and work your way out, right? What I want to know is what is g of 1? So when x is 1, right? What's the y value? It's 3, right? So this means that I want to know what is f of 3. Very simple. So when x is 3, right, the y value is 6. So this becomes 6. That's how we do that. F of g of 1. Now, let's look at g of 5, right? So g of 5, right? So g of 5, next value is 3. So this is going to be what is g of 3. So when x is 3, the y value is -1. All right. Last but not least, f of 3. What does that mean? That means I want to know what is f of 3. Just like that, right? So f of 3, so when x is 3, right? This is going to be 6. This becomes f of 6, which is, when it goes to 6, this is going to be -3 right here. And that's it. So for the composition, plug them in, work on the inside first, and then work your way out. Right? Work on the inside first and work your way out. And that's it. All right. Now we want to find the inverse of f of x, right? So very simple. You have y equals 2x over x minus 2. To find an inverse, switch x and y. So look at this. Now I'm going to make this x equals 2y over y minus 2. And very simply, just solve for y. Right? So I'm going to multiply by y minus 2 here. You do to one side, you know you got to do it to the other times y minus 2. So now I have x times y minus 2 is equal to 2y, distribute. So I have xy minus 2x is equal to 2y, right? So what am I going to do? Subtract xy from here. And now I have what? Negative 2x equals 2y minus xy. Greatest common factor, factoring out the y, I have negative 2x is equal to y times 2 minus x. Divide by 2 minus x. And that's it. All right? This is my y inverse. All right? Now they want us to verify that this is the actual inverse. And how do you verify it? You actually plug in one into the other. So I'm going to find, hold on one second. All right, everyone, sorry about that. Actually lost our last problem there. All right, so let's pick up where we left off. I wanted to do f of f inverse of x. Right, so I'm literally taking the inverse and plugging it in. So this is going to become 2. Now, if this equals x after I'm done plugging it in, then it is in fact an inverse. This is what I'm verifying right now. So this is 2 times negative 2x over 2 minus x, right? Over negative 2x over x. Let me say that again. Over 2 minus x. There we go. Minus 2. Okay. So I took the inverse and I plugged it into f of x. So let's see what happens. Let's do the math. Let's see what happens, right? So for this, think of this as like 2 over 1. This is just negative 4x over 2 minus x. And this is like over 1. So I need to expand the bottom. So this is going to be for me negative 2x. Come on, negative 2x minus 2 times 2 minus x all over the 2 minus x. All right? Distribute this, of course. So I have, let's come down, negative 4x over 2 minus x over negative 2x minus 4 plus 2x all over 2 minus x. Let's combine like terms. What do I have? I have negative 4x over 2 minus x over, right? These will cancel. Negative 4 over 2 minus x. All right, let's simplify this. Keep change flip. This is negative 4x over 2 minus x. Now we're going to change that to multiplication. Flip the bottom. This is 2 minus x over negative 4. Let's cross out the like terms, shall we? Right? So boom, 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 boom. Final answer is just x. So this is in fact an inverse, right? This is part B. We verified it. Bam, and we found the inverse, right? Now I said that they want us to sketch the graph on the same coordinate grid. Let's do that. All right. Let's take a look at these real quick before we jump into them. So I see I have an asymptote at x equals 2. I'm looking for f of x right now. At x equals 2, I have an asymptote. And other than that, it doesn't really matter what I plug in, right? So x equals positive 2. So 1, 2. That's x equals 2. Let's see if I have a horizontal asymptote, right? And I do at y equals 2. So let's look at that. 1, 2. This is a line y equals 2, right? So now what I have to figure out is where am I, right? So I want to know what's happening before positive 2. So let's go with 1. If I plug in 1, I get 2 over negative 2, right? And 2 over negative 2 is negative 1, right? So at positive 1, I'm also at negative 1. So this is like here. This is a point in the graph right here. So what is that telling me, right? That's telling me that this graph is doing something interesting. If I plug in 0 for x, I get 0. So it is going to cross the origin as well, right? So that's the point 0, comma 0. This is the points 1, comma negative 1, 1, comma negative 1, right? These are going to go close to the horizontal and vertical asymptote, but never actually touch. There we go. This is f of x, by the way. And the next one I'm going to do is going to be the inverse, right? So let's take a look at the inverse. So setting the denominator equal to 0, I notice that there's an asymptote at 2 as well, right? Now, it doesn't matter anything else beyond that. I have, let's see, there's a vertical asymptote at positive 2, same thing, right? So that's good. That's good. That's good, right? Now, all we got to do is figure out what happens like when we graph some of this. Let's plug in 1. If I plugged in 1, I would get negative 2 over 1. So that's negative 2. So when x is 1, you're at negative 2. So here. 1 comma negative 2. If I plug in 3, let's see what happens. I get negative 6 over negative 1 positive 6. So at 3, that's 2, this is 3. I'm at positive 6. So 3. And then at positive 6. So somewhere up here. 3 comma 6. All right. Let me try that one again. Plug in one. I get -2 over +1. So negative. So at one, it's -2. Hmm. I feel like this is gonna be an inverse that's gonna do something like this, but I'm trying to shape it out. Trying to shape it out. It should do something like that, actually. Okay, so we actually have a double situation going on. I feel like I didn't plug in three on the other side either, right? So when I plug in three, that's six. Yeah, that's +6 also. So three and +6. So yeah, these graphs look almost identical to one another. So what I would do, play with your table of values to verify what you have when you see this type of question. Right? Plug in the numbers. Remember all your information, right? You want to look at your vertical asymptotes, horizontal asymptotes, right? We want to look at our end behaviors if possible, right? 2x over x minus 2. Yep, so I just graphed both of these. These graphs appear right on top of each other, verbatim, right? They're just right on top of each other. That's how these graphs look. Okay. All right, so let's move on. All right, couple more problems left, then we're good. We want to find an inverse of this. So I have y is equal to 4 over 3x minus 7. I want to switch the x and the y. So then this is going to become what? X is equal to 4 over 3y minus 7. And let's solve for y. Multiply by 3y minus 7 on both sides. All right. So what do I have? I have x times 3y minus 7 is equal to 4, right? Sorry, I don't know why it's not drawing. Distribute that x. I have 3xy minus 7x is equal to 4, right? And then now, solve for y. I'm going to add 7x over here. So I have 3xy is equal to 7x plus 4. I'm going to divide by 3x. What I do to one side, I have to do to the other. So there we go. That's my inverse, right? So y inverse is equal to 7x plus 4, all divided by 3x. There we go. All right. Just make sure that's charging. Good. Okay. That's all that question was. All right. Oof. A through H. All right, let's go. So first things first, right? I want to start off with A, right? We want to find the domain. So we're gonna go from what to what? For A, we're going from -3, open parentheses, -3, all the way up to +1. That's our domain. All right. For B, our range, we're gonna go from -4 all the way up to 0. All right, so the bracket on that one, sorry. So I'm gonna go from -4 up to 0 bracket. That's my range. Over which interval is this increasing, right? So we're increasing from -2 to 0. So from -2 to 0, we're increasing right from here to here, right? And then D, over which interval is it decreasing? So for D, we're going from -3, not included, all the way up to 2, not included. That is going to be our A, B, C, D, decreasing, right? And from 0 to 1, we're also decreasing, right? A, B, C, D, E. They want F of -3. So when X is -3, this does not exist. And F of -1 is equal to -2 right here, this point, right? And X is -1, Y value is -2. Okay, F. So find all the solutions of F of X is equals to -4. Okay, so let's go down to where -4 is. I'm looking at these 2 points right here. So this point is 1 comma -4, and this point is -2 comma -4. All right. All right. So for F, right, what are my solutions, right? So I have -2, this equals -2, and X equals 1. All right. G, we want all the zeros, right, of this function, right? So we have a 0 at 0, so 0 comma 0. Right? And it asks, does this function have an inverse function? We could find an inverse function. We just have to reflect it over y equals x. So I would say yes. Actually, wait, no, no, no. Take that back. 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 To be an inverse, right? If I'm not mistaken, you have to be able to reflect over y equals x, implying that you are one to one. And this is not a one-to-one function, right? Because it would fail the horizontal line test. So I'm gonna go on a limb and I'm gonna say no, right? For H. It doesn't have a inverse because, right? It's not 1 to 1. Okay. Okay. All right. All right, so we have f of x is equal to x squared minus 1 over x squared plus 2x minus 3. All right, it says factor the numerator and denominator and simplify if possible. Let's do it. So I'm going to have f of x is equal to, top is x plus 1, x minus 1. Difference of two perfect squares. Bottom is going to be x plus 3 and x minus 1. Right? Boom. Right, and then we could simplify this, cancel these out. X plus 1 over x plus 3. Right? B, we want those y-intercepts, those x-intercepts. So, right, the x-intercept, we're going to set the numerator equal to 0. Right? So I have x plus 1. Right? And I have, I don't really want to set the other one equal to 0, but technically speaking, you could. Right? Minus 1, minus 1. So we have x is equal to -1, right? Remember, anytime we have a factor like this, that's going to leave a gap, right, in our graph, right? We're going to have a gap in there. So x equals -1. Boom. It's my x-intercept, right? So -1 comma 0. There we go, right? What else do we have? Y-intercept. Plug in 0 for this. What do I get? Let's see. If I had 0 plus 1 times 0 minus 1 over 0 plus 3 times 0 minus 1, this would be what? -1 over -3. This would just be 1 over 3. Right? So y-intercept, right? This is when x is 0, we had 1/3. Right? Just thinking for a second. All right. So any vertical or horizontal asymptotes. So for vertical asymptotes, you want to set the denominator equal to 0. All right. Okay, so we have x is equal to -3 and x is equal to +1, right? So there will be a vertical asymptote at these points, right? Horizontal asymptote. Let's look back at the original question and do that. They both have x squared, so there's going to be a horizontal asymptote at y equals 1. There we go. All right. Let me go back to the question. What else did they want? Now we're just going to sketch the graph. Determining how it's behaving is just sketching the graph, right? -3, 1, 2, 3. Y equals 1. All right. We're going to have a gap at x equals 1. Okay. In a sense, you want to be able to plug in some numbers here, see what happens. So if I plug in a number, I cannot plug in -3, but if I plug in like -4, I notice I have a negative, 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 negative. So positive over positive. So at -4, it's positive. So I'm assuming we have something like this going on, which implies that this should have something like this going on. Not quite. There we go. And then I'm crossing the x-axis at, let me see, -1 comma 0. So I'm wrong here. Now we have 0, 1/3. Right. So would that be going on like that? Trying to think. 0, 1/3. So I'm crossing the y-axis here. Okay. And then -1 comma 0. Okay. So I believe something like this is going on. And that's it. There goes your graph. All right. Made a mistake. I didn't put my labels. All right. 0 comma 1/3. -1 comma 0. Always let me see those points and we're good to go. All right. Labels are important. I think we're gonna call it at that. All right. You guys, good luck on your exam. Study hard. All right. I'm the tutoring if you have any questions.